You look at screens every single day, but behind the apps, the websites, and the games you use, there is a hidden layer. It is a world of pure logic that organizes every click and swipe. A lot of people think you need to be a math genius to step into this world. You don't. Programming is simply learning a new language so you can give a machine a clear set of instructions. Every piece of software relies on a simple, three-step process. First, you figure out the logic of what you want to happen. Second, you translate that logic into code. And third, the machine reads your code and gives you a result. Once you learn how to communicate in this language, you can write your own rules for how technology behaves. You go from using tools to building them. If you want to understand how computers think, the best place to start is the C programming language. In the software industry, C is known as the mother of all programming languages because so many modern systems are built on top of it. To see why it is so heavily relied upon, we have to look back to 1972. A computer scientist named Dennis Ritchie developed C at Bell Laboratories in the United States. At the time, writing software for a computer was a grueling manual process. Ritchie designed C to run on early hardware, specifically a massive machine called the DEC PDP-11, to make it easier for developers to build entire operating systems. Modern programming languages often hide the hardware details from you. C doesn't. Learning C strips away those protective layers and shows you exactly how data is stored, moved, and processed in the computer's physical memory. Before we write a single line of C code, we need to understand the tools at our disposal. Almost every programming language relies on four physical concepts. The first concept is variables, storage containers that hold specific data, like numbers or words. The second concept is arrays. An array snaps these containers together in order, storing related data in a continuous row of memory. The third concept is loops, an automated cycle. If you need to perform a task 50 times, you tell the loop to repeat. Finally, pointers are special variables that hold the exact physical memory address of another container. Typing the code is just the final step. The real skill is learning how to arrange these variables, arrays, loops, and pointers to solve a problem. When you arrange those concepts on your screen, you write source code. You type this using English words and logical structures that are easy for humans to read. Your computer hardware only understands binary electricity. That is where the compiler comes in, translating your English words into binary strings. The processor then reads those ones and zeros and delivers the final result to your screen. You never have to manually write in binary. As long as you can learn the rules of C, the compiler will handle the complex job of talking to the hardware for you. C has its own specific vocabulary, like keywords, which are fixed words with special meanings, and syntax, which is the set of grammar rules for where every bracket and semicolon belongs. To keep it simple, we will tackle these one step at a time. We will start with the installation, building a foundation with basic variables and loops to control data. Then we move up the skill tree. You will learn to use pointers to manage memory and structures to organize complex information. By following this sequential path, you will move from your first line of code to having a firm grasp of programming fundamentals. Every expert developer began exactly where you are sitting right now, looking at a blank screen. Because C allows for such precise control over hardware, it is often chosen for systems that require absolute reliability. The logic you are about to learn is the same logic used to keep complex machinery running smoothly. It is time to take control of what happens on your screen. Build logic. Understand computers. Become a programmer. Let's start learning C today.